Okay, so this one, it's a little bit of a chain rule going on. So my thing with the chain rule is there is a much longer way to do it. But I just think in a test like this, you need to employ these shortcuts that you can find. So what I have is sort of this is looking a bit like this. Okay, so we have this situation. I'm just rewriting out what I've got there. Now what I'm going to personally use with this is I'm going to call this inside here a function of x. Right, I'm just going to call it f of x. And I'm going to let my rule sort of speak for itself here. So let's say that we've got g of x is equal to, in brackets, we've got an f of x, which is going to some power a. Okay? So what I'm going to do with this is actually, my rule is essentially a multiplied by the original f of x, and on the outside of the bracket, f dash of x. All right? Now that might look a bit dodgy, but when you apply it in this question, you'll see it doesn't work out so badly. So in this case, this is my a. All right, so the way that this is going to work, g dash of x is equal to 3 multiplied by the original function, which is this, multiplied by the function differentiated that's inside that bracket, which in this case is just going to be negative 3x squared. Now, to simplify, I mean, I don't even need to simplify, to be honest. I can just go straight from here, because all I'm evaluating is g dash of 1. So I'm just going to sub this in from here, because I don't want to make any more mistakes than I need to by doing too many lines of working. So 2 take 1 cubed, multiplied by negative 3 times by 1 squared. Now, there's a lot of negatives and things floating around in here, and that's where a lot of mistakes are going to be made with this. Just be careful, keep things in brackets until the last minute where possible. So 2 take 1 cubed, this is just going to be a 1. And then inside here we've got 1 squared. And then this is being multiplied by negative 3. So we've got negative 3. So at the end of it, we've got 3 times 1 times negative 3. So we've got negative 9. And there's our answer.